log laws do you know? How do they work? I'm going to ask you for some volunteers, and remember what I said about at the start. It's easier, it gets harder. So does someone want to volunteer one of the log laws? Anyone? Hands up. Yeah, Amelia? Log, say it again. Now, you said log A, B. Now, what do you mean by that? Log A, B. Like that? Okay, is equal to? Log A plus log B. Good. Okay, correct. Now, by the way, just while we've got it on the board, test for you. If you were to see this, that exact line, written, say, in an exam, what base would you expect it to be?
E.
10.
Hands up! Hands up! Actually, we'll do it this way. Hands on your. Don't do it yet. I'll tell you to do it in I'll count down. Put your hands on your head if you think it's base E, and put your hands on. Where else can we do? Cross your arms if it is base 10. Usually when you do hands and balls, but you're all seeing now. Cross your arms if you think it's base 10. Okay, I'll count 3. Ready? Ready? 1, 2, 3. We're pretty mixed. Okay, and the answer. What I said was heads. Was that E?
Yeah.
Yeah. Okay, and the answer is. The answer is E. Now, by the way, though, the people who said 10.
This one, did you say?
No, she said it's not 10.
The people who said 10 are in good company because our friends at Casio define LOG, just that, as base 10. And you can tell because if you've got your calculator there, on top of where it says LOG, what's on top of where it says LOG? Anyone see it?
10 to the power.
It says 10 to the power of, which is your clue that when they say LOG, they're really talking about scientific notation. That's what it's used for. So that's why it's base 10. Okay? However, if you're not, that's so scientific notation, like applied maths and all that kind of thing, it's kind of second grade. So if you're a real mathematician and you just write LOG, you actually mean base E. Okay, but to be unambiguous, how would we normally write that if we wanted base E? You write LM, which stands for?
Natural.
Yeah, natural, because E is the important number. Do you remember last time, or the time before that, we were looking at E being the number that was about, what was it about? It's equal to 2.7182, but where did it come from? Where did it come from? It came from the limit of what kind of growth? Yeah, that's right. And logs are about the time that exponential growth takes. Anyway, that's a conversation another day. Bonus marks. I'll admit, I start off easy, but this is dropping in the deep end a little bit. This is the log law. What's the index law that's the equivalent or the flip side of this log law? Because all the index laws and all the log laws are really the same thing, just you look at it from 2 different angles. What's the equivalent?
X to the power.
Yeah, whoa, flying markers. Yeah, other back bench.
E to the power of A plus B equals E to the power of A times D to the power of B.
Yeah, bingo. Good. Okay. So the way you're seeing it, right? Whenever I have trouble remembering what the log laws are, I mean, most people tend to know their index laws quite well because you learn them a lot earlier. Okay. So if you know this, that's how you get this. Right? If you ever keep is it adding goes to multiplication or the other way around, right? Write your index law and then you know it's the reverse for the log law. Okay? Alright, so that's one log law. We got one. That's actually kind of a hard one to start off with. Can someone give me a simple one?
Log B on A.
Log what?
B on A.
Log
B
B on, okay, yeah?
equals to log B.
Okay, sure, I'll pay it. It is true. Though it's kind of,
I'm sorry.
it's yeah. Let the team down, Oscar. I am disappointed. Okay, fine. We're really rewriting this, aren't we? Because multiplication, division, same deal, just in reverse. Okay. Another one. Yeah, Ken.
Log A to the base of A
the way, in some ways it doesn't matter all that much, but the way I would read that is log base A of A. I find that's a little less ambiguous. Log base A of A. I'm actually reading it left to right. That's it. It's true. Okay, that's 3. Another one. Yeah.
Log of a squared equals 2 log a.
Log of A squared. Let's generalize it, shall we? Because this is log laws, right? So suppose it weren't squared. Suppose it were 2. Let's make it n. Okay. What's it equal to? Good. Okay. Fantastic. Another one? Yeah, Ren.
Log to the base a to 1 equals 0.
Fantastic. Okay. Again, what's the equivalent index law here? A to the. Oh, that was pathetic. Come on, let's try again. Or
To the 0 equals 1. Uno.
it was the same, just louder. Like it was okay. Fine, good. You obviously you can do this for all of them, right? Okay. Anything else? Change of base. Yes, good. Which is critical. How do you do change of base? Let's do, say, log base A of B. How would you change the base? Okay. Log B over log A. In some ways, even though that's a tricky one of the laws, it's easy to even see because I always picture it as like the B's on top and the A's on the bottom, so that's what it becomes when you take logs of each. What base do you need to take the logs in? Ah, you 10 people really love 10, don't you? Answer is, you can take any log base, can't you? You can take natural log, you can take 10, wouldn't matter. Okay. In fact, you'll often see this, okay, with a C down there signifying it can be any constant you're following. Okay. That looks pretty good. Happy with that? Yeah, I think I'm pretty happy with that. Okay. So we know lots of things about the logs, all of these laws that allow us to manipulate them, but can we differentiate them? Okay. So taking a step back, subheading. What was the derivative that we looked at, or actually a pair of derivatives, that we looked at last lesson? Do you remember? We had a look at one particular kind of derivative, and then we looked at a special case of the same formula. Anyone remember? Derivative of something. What were we looking at? We were looking at, broadly speaking, exponential functions with any kind of base, right? But we particularly looked at 2, didn't we? Okay. What was it equal to?
E to the power of x log a.
Yeah. So that's what we determined. We used our calculators to help us there and some limits and that kind of thing. And then the special version of that we looked at was e to the x. Okay? Which is e to the x log e, natural log e, which of course is just 1. And that's what we got this from. Okay. So now my question is, this is why we're looking at all of these log laws and that kind of thing. If we understand the exponential function, right, and particularly the natural log function, is really just the flip side, the inverse function of the exponential. Okay? If you know something about 1, just like here when we're looking at this law versus this law, you know something about 1, it necessarily tells you about the other. Okay? This is the way it always is in maths. It's very symmetrical. Okay? So my question is, what's that? Okay? Now, I don't want you to shout out, but does anyone actually know the answer? Anyone? Yeah? Small number of you? Okay, hands, a few of you, right. Hands out. Now here's what I want you to do. For those of you who are like, what does that even mean? Are there even numbers on the board? Are we doing maths? Okay, for you, I want you to see if you can work it out. This is what I'm going to remind you of. That's the definition of the natural log. Okay? Just on your own steam. Just play with it. See if you can come up with anything meaningful. For those of you who do know what the answer is, I want you to see if you can prove it. Okay? Don't assume anything. No formulas, except for what's on the board. Okay? See if you can give it a go. If you think you have a proof, call me over. All right? While I'm doing that, I'm going to mark the roll.